another thing about storms, just wanted to cut right to it. You might say storms are just a nuisance. Well, they're part of the climate system, and it's part of nature's attempt to balance distribution of heat and moisture and angular momentum, but we won't get into that, between the equator and the pole. So there are means of transporting moisture and transporting heat towards the poles. Likewise, mid-latitude lows also bring cold air down from the north. So it's a kind of nature's attempt to homogenize things a little bit. The poles are still cold, but they would be colder if we didn't have these storms transporting moisture northward. The poles are dry. Polar deserts, you may hear, but they tend to be dry. Would they be drier if we didn't have moisture being transported towards the poles? So that's kind of just a general, simple explanation about storms. We need these storms. People who say we should eradicate hurricanes. We might overheat our equatorial and subtropical zone if we couldn't take some of that heat from the oceans and get it towards the poles. Likewise, we could get real cold to the north, and that could result in colder air and ultimately stronger middle latitude lows. So there's a reason why we have these things. We just have to be aware of them, be able to forecast them well, and take heed of any warnings to get out of harm's way. Here are the conditions necessary for tropical storm formation. Now, mind you, this is a rather cursory look at things, but you need warm water, and that's like bathtub type of water to generate a storm. And you need an unstable atmosphere, to a point. You don't want the atmosphere to be all that unstable, or the storm will get ripped apart before it even gets started. But you need enough instability that you're going to start percolating, and there's latent heat, a lot of evaporation from this warm ocean surface, but it's got to meet something in the atmosphere above that's a little unstable to help get things spinning, to help get the air rising in the atmosphere. But you don't want it too chaotic, if you will, up at the upper layers of the atmosphere, what we call shear, because that will start ripping the storm apart from all different directions. So the tropical storm wants to, as I said, percolate in this warm ocean, and real warm. And that's why they don't generate far to the north. They don't sustain themselves far to the north in the ocean. And once you get them over land, because you don't have that fuel from the evaporation of all that warm ocean water, and you also have trees and mountains and hills and whatever that cause what we call frictional effects that kind of rip the storm apart down at the surface, let alone aloft. Storms start falling apart when they come inland. So in order to sustain these tropical storms, you've got to, and have them grow and really prosper, you have to keep them over warm waters in an environment, an atmospheric environment that's not prone to winds coming in from all different directions at all levels. So they just bubble up. And the next shows you kind of a picture of that as you get your air down near the surface starts coming in towards the storm, and it will rise around the eye. Then, nature, well, I'd love to say abhors a vacuum. So you have to fill in air from somewhere. So you get air coming down, dry air coming down into the middle of the storm. And all around that storm, you've got spinning winds, rising air, all kinds of precipitation forming. You can spin other events off of these heavy rains and so on and so forth. So that's the general picture. But notice, you don't see anything there that says cold air here, a cold front here, a warm front there. This is an isolated system that's just growing, developing, and prospering depending on the conditions in place.